Hello everyone. Today we are continuing the method of elimination. We will have a bit more complicated examples. So let's get started. Okay, so first of all, let's take a look at this and think what is different about this problem. Well, if you look at this, first of all, there's no variable with a coefficient of 1 or -1. And as well, there's no easy choice for elimination. 2 and 5 are not multiples of each other, and 9 and 8 are not multiples of each other. So what are we going to do here? So we actually are going to need to multiply both equations. So there's no easy choice for elimination. And so we will need to multiply both equations. So which one do we want to have a coefficient that is the same? Remember, we need coefficients where one is plus the number and the other one is minus the number, or minus and then plus, the same number. So we're going to work with the coefficients of x. Why are we choosing the coefficients of x? Because though they have smaller numbers, that's the only reason. So we want to work with the coefficients of x, and we want the coefficients to be plus 10 and minus 10 so that we can eliminate. So this first equation we need to multiply by 5 so that we will get a positive 10 here. And the second equation we need to multiply by 2 so that we will have a negative 10 here. 10 and negative 10 will eliminate. So let's do that down below. So equation 1 times 5, and put a colon, that gives us 10x minus 45y equals 40. Okay, and now let's do equation 2 times 2, colon. So that gives us negative 10x plus 16y equals negative 40. Okay. Now you may notice that, sorry, that should have been a 40. This is positive 40 and negative 40. So those will also eliminate, but don't worry about that. You'll see what happens with that. So the 10 and the negative 10 eliminate. That's what we wanted. Then we have the negative 45 plus 16, which gives us negative 29y equals 0. So notice that when we divide both sides by negative 29, we still just get 0. So that just means y equals 0 is part of this solution. Then we solve for x. So 2x minus 9 times 0 equals 8. So 2x equals 8, x equals 4. So the solution to this linear system is 4, 0. Okay, so let's try another one. So here's one of those your turns again. So I would like you to try this. But first, let's decide together, you know what I mean, what variable we're going to eliminate. So x looks really nasty because there's a 13 and a 4. We don't want to deal with that. So let's work on eliminating y. So we will have coefficient of negative 6 here and positive 6 here if we multiply this equation by 3. Okay, and you can write it there. And then multiply this equation by 2. And you can write it there. All right, so do that now. And pause the video. Okay, and actually do that now. And then go ahead and solve for x. So what you should do is multiply the first equation by 3. Multiply the second equation by 2, and then add them together and solve for x. So go ahead and do that now. Okay, you should have gotten that x is equal to 1. All right, so now you sub x back into one of the equations and solve for y. So again, pause the video until you've solved for y. You better pause. Santa's watching. Okay, so you should have gotten that y is equal to negative 6. So your solution here is 1, negative 6. And again, if you weren't able to get that, that's fine. Please just make sure you see me in tomorrow's class or the next class. Okay, yet again, there's something different about this example where, in this case, first of all, there's fractions, and second of all, these are not stacked. Okay, so they're not, the equations are not what I call stacked. There's not x's on top of x's, y's on top of y's, that situation. So we need to put them in the same order, and I also want to get rid of the fractions. So I'm going to call this equation 1 and this equation 2. So with equation 1, I'm going to put the x over here. So minus a half x plus y equals a half. And then equation 2, I get 3x plus 2y, but I want to put the 13 on the other side. So I get equals 13 if I take this minus 13 and move it over. Okay, now I really don't like these fractions, gotta be honest with you. So I'm going to multiply this whole thing by 2 just to get rid of the fractions. So I get negative x plus 2y equals 1. And then 3x plus 2y equals 13. Okay, so now you have two choices. Notice that the y's are both 2. So either you can multiply one of the equations by negative 1 and then add the two equations, or we can actually subtract the two equations instead. Okay, so negative x minus 3x is minus 4x. 2y minus 2y eliminates, and 1 minus 13 is negative 12. So then if we divide both sides by negative 4, we get that x is equal to positive 3. Now, all we have to do is put 3 back into one of the equations, and you will get that y is equal to 2. Okay, I'm just skipping that step because I'm confident that you can do this by now. So your solution is 3, 2. All right, so I have one more for you to try on your own. So again, the big problem here is that the equations are not stacked. So you should move it around so that they're stacked one on top of the other. And then you can feel free to eliminate. So hint, 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 just move this x over here by adding x to both sides. Then they'll be stacked. Okay, so you should get the solution to this one is 6, 2. Again, please don't let it go if you didn't do it or you tried it and you didn't get it. Absolutely talk to me. You don't want to let these things slide because the math will get hard much more quickly than you can manage. Okay, so finally, let's go through just the steps for solving any linear system using elimination. Okay, and you can have these steps out with you while you're still learning how to use it. So here we have two equations. So we want to arrange them so that they are aligned. So we want to stack them one on top of the other. So in some examples like the ones we just did, you might have to change the order, or sometimes you simply have to write them one on top of the other. So that's the case here. So 4x plus 3y equals 15, and 8x minus 9y is equal to 15. Now you want to choose the variable which you want to eliminate. Okay, so in this case, it'd be relatively easy to eliminate x or y, so you need to make a choice. I'm going to choose to eliminate y since one is already positive and one is negative. Okay, so now if it's necessary, you multiply one or both of the equations so that they have the same or opposite coefficient in front of the variable we wish to eliminate. So I want to eliminate y, so I want the variables to the coefficients to both be 9. So I want this one to be positive 9 and this one to be negative 9. So if this is equation 1 and this is equation 2, I'm taking equation 1 and multiplying it by positive 3. So that gives me 12x plus 9y equals 45. Okay, so then I add and subtract to eliminate one variable. So then I add that to equation 2. So equation 2 is 8x minus 9y equals 15. So I add these together and I get 20x equals 60. Okay, so now I'm actually on step 5. So I solve for the variable. So x is equal to 3. Since I would divide both sides by 20. Then you substitute x equals 3 into one of the original equations to find the value of the other variable. So I would take, for example, let me see here, 4x. So 4 times 3 plus 3y equals 15, and solve for y. So 3y equals 3, okay, because this is 12 and I'm subtracting 12, and y is equal to 1. So my solution is 3, 1. I write the x first and then the y. And then I can verify left side, right side in both equations if it calls for it or if I'm doing an assignment, okay? If you're doing an assignment, you should always verify using left side, right side if you're not restricted on time, okay? That's where your thinking marks will get to a level 4 if you show me this verification. On a test, you don't need to verify unless I ask you to, but it is a good idea to verify if you have time, just so you know that your answer is correct. Okay, so there you go. That is the rest of elimination. Please read the success criteria. Thanks for watching, and I hope you learned lots.